Okay, so let's jump right in. Most of us are pretty familiar with the big cybersecurity frameworks, right? Things like NIST CSF or ISO 27001. But today we're talking about a whole new frontier, artificial intelligence. And you might be thinking, wait, why do we need a completely new rulebook for this? Well, the short answer is that AI systems are just a different kind of beast. They don't just follow lines of code, they actually generate their own outputs, things like predictions and decisions that have a real impact on our world, often with a mind-boggling amount of autonomy. So here's our roadmap for this explainer. First, we're going to dig into why AI even needs its own set of rules. Then we'll introduce NIST's big answer to that problem, the AI RMF. After that, we'll break down its 4 core functions, which is really the how-to part. Then we'll talk about what it even means for an AI to be trustworthy. And finally, we'll wrap up with how you can actually get started with all this stuff. All right, let's kick things off with the big question. Why can't we just use the playbooks we already have? Well, it turns out that AI brings such a unique set of risks to the table that our old guides, they just don't cover all the bases. Let's really get into this. The heart of the problem is predictability. Traditional software does what it's told, right? It follows rigid, human-written logic. But AI systems, they learn, they adapt, they evolve. And that amazing ability is exactly what creates these entirely new kinds of risks that, honestly, we've never had to manage before, especially not at this scale. So just to make sure we're all speaking the same language here, let's use NIST's own definition. An AI system isn't just another piece of software. It's a system specifically engineered to produce outputs that have real-world effects. Think about anything from a medical diagnosis to whether or not you get a loan. And it does this with some level of independence from a human operator. This slide right here really drives the point home. With old-school software, the risks are usually pretty predictable, pretty contained. A bug might crash an app, which is annoying. But with AI, the risks can be systemic. A biased algorithm could unintentionally affect an entire community's ability to get jobs or housing. These dangers can pop up in totally unexpected ways, sometimes long after the AI has been released. So, to deal with this brand new reality, NIST got a bunch of smart people together, experts from government, academia, and the private sector. And their mission was to create a solution built from the ground up for this challenge. The result? The Artificial Intelligence Risk Management Framework, or as we'll call it, the AI RMF. Now, it's super important to understand what the AI RMF is, and maybe more importantly, what it isn't. This is not a law, it's not some rigid compliance checklist. It's a totally voluntary resource. It's designed to be super flexible, so it can work for any industry or any AI use case. And, I think this is key, NIST calls it a living document. That means it's built to grow and change right along with this incredibly fast-moving technology. So the whole framework is about one thing, managing AI risk. But check out how broadly NIST defines that risk. We're not just talking about a data breach or losing money. It's about the probability of a bad thing happening, multiplied by the size of the consequences. And those consequences could be for a single person, a whole company, or even the entire planet. The stakes are high. Okay, so that's the big picture. But how does this framework actually help you do something about it? Well, it breaks down the huge job of managing AI risk into 4 main functions. And hey, if you're familiar with the NIST Cybersecurity framework, this whole setup is going to feel very, very familiar. This diagram you're seeing is basically the heart of the framework. It's all built around these 4 functions: govern, map, measure, and manage. And notice how govern isn't just the first step. It's right there in the center. It's the hub that connects and powers everything else. So let's break down what each of these means. First up is govern, and this is the foundation for everything. It's all about creating a culture where people actually take AI risk seriously. This means having clear policies, making sure someone is accountable so everyone knows who owns what, and just getting the entire organization, from the top executives down to the engineers on the ground, to really adopt a safety-first mentality. Next, we have map. And this is just common sense. You can't manage a risk you don't understand. The map function is where you lay it all out. What is this AI supposed to do? What are its limitations? And most importantly, who or what could be affected by it, for better or for worse? You got to map the whole terrain. So once you've mapped out the landscape, it's time to measure. This is where you get analytical. You start using actual tools, some quantitative, some qualitative, to really assess the risks you identified, tracking them with real data to understand how likely they are to happen and what the impact would be. And finally, we get to manage. This is where the rubber meets the road. Based on everything you've learned, you prioritize those risks, and then you decide what to do. And that doesn't always mean trying to eliminate the risk completely. You might mitigate it, transfer it, or you might even make a calculated business decision to accept it. It all depends on your organization's tolerance for risk. Okay, so we've got this process, right? Govern, map, measure, and manage. But what's the end game here? What are we actually trying to build? Well, the framework is super clear on this. The whole point is to create AI systems that are, in a word, trustworthy. This visual from NIST does a fantastic job of showing what trustworthy actually means. It's not just one single thing. It's a whole bunch of characteristics working together. And look at the bottom. Everything, and I mean everything, rests on that foundation. The AI has to be valid and reliable, because if it doesn't work correctly and consistently, none of the other stuff even matters. So a trustworthy AI is about so much more than just getting the right answer. It has to be safe to use, it's got to be secure from attacks and resilient enough to bounce back when things go wrong. It has to be accountable and transparent, protect user privacy, and, this is a huge one, it has to be fair, with real processes in place to find and manage harmful bias. If you miss any one of these, you risk failure. I really want to zero in on this one, explainable and interpretable. This is so critical for building trust. We've all heard stories about AI hallucinations, right? Where a system just confidently makes stuff up. Well, explainability is the antidote to that. It means building AI so that a human can actually look inside and understand why it made a certain decision. Without that, you risk what the framework calls human AI configuration errors, like a doctor blindly trusting a faulty AI diagnosis, which could lead to a total disaster. Okay, I know this has been a ton of information to take in, but the really great news is that NIST has put together a mountain of resources, so you absolutely do not have to figure this all out on your own overnight. They've made it really easy to take those first steps. So if you're sitting there thinking, where do I even start? Here are 3 simple, practical steps. First, just go online and explore the NIST AI Resource Center. It's the main hub for everything. Second, download the AI RMF playbook. It is packed with hundreds of specific, tactical things you can do. And third, check out the real-world use cases to see how companies like Workday are already putting this framework into practice. You don't have to reinvent the wheel. So I want to leave you with this one thought. AI technology is not sitting still. It is learning and evolving every single day at a pace that is just staggering. And so the really powerful question this framework makes all of us ask is pretty simple. Is our strategy for managing its risks, learning, and evolving right along with it?